Wow, this is a massive turnout. A very warm welcome from my side. I'm Adrian, co-founder and GP of Merantix Capital. We are an AI-first investor, invest in a lot of different industries. We might touch a few of them today. We are part of the wider Merantix group, which is also the owner of the place that you found yourself in, the Merantix campus, which today has 1,600 people working in machine learning. I'm gonna let my wonderful guests on a panel introduce themselves, Jessica and Christian. Maybe you start with a quick introduction about yourself and also why does the energy topic matter to you?
Sweet, thanks a lot and thanks for having me. Very happy to be here and see so many of you. So I'm an investor at Planet A Ventures. We're an early stage venture capital fund which backs founders with bold missions in the environmental space. We have made a few investments already in energy and AI and very excited about future opportunities here, which is why, yeah, I'm excited to see so many of you also interested in the topic and maybe building something here.
Good morning, my name is Christian. I've been in the energy space for the last 18 years in consulting, later in international companies, managing power and gas. And I'm very excited also to be here with you today.
So, on our Christmas party in 2019, my team, we did a few theatrical things there, and people were mocking each other. And a part of the team that was taking my role had to mock me, and the way they mocked me was basically by doing a fun story about something I continuously said that time, as in AI is going to be in everything, in every aspect of our lives. And they made a lot of fun of it, and I had a lot of fun too. And obviously today it's very true, right? So AI is practically in every aspect of our lives. And so it is in energy. So that's what we're going to talk today. And Christian, in our preparation, you asked me not to talk about one specific thing. And of course, I'm going to start with that. So you told me not to talk about, AI running the grid. So tell us about AI running the grid and why you don't think that would be a good idea, aside of the, Terminator, like Cyberdyne. So let's start spicy.
Sure. So actually, I think the power grid is already quite automated. Yeah. So actually, it's the only way to operate grids. And I think explaining today that we found the world formula how to solve the power grid would be a bit too much. So, but I think if talking about AI, it's always hard to distinguish what do you actually mean by AI, because I think it's also a kind of a buzzword. And I think we need to distinguish a bit. So my personal take is AI is actually a subset of machine learning that has been used for 20, 30 years and conceptually already since the 50s or so. And AI, especially, let's say, what currently we consider as AI is more or less all the crazy hype about LLMs and about those kinds of things. And I think I wouldn't use a large language model to operate a power grid, because maybe it has a hallucination and then we all sit in the dark. Yeah. So this is why I think LLMs should be used where appropriate. And also we should find means to control them in a better way, to have some guardrails in place, and to also say when can we trust an answer and when not. That's a bit my personal take.
So obviously energy is one of the most fundamental parts of our lives today. And I'm sure, Jessica, you've also been thinking a lot around what energy can do, and what kind of ventures you would wanna invest in. So maybe talk us through the last couple months. What kind of ideas have you seen that you were impressed with? But maybe also what are areas that you would not invest today or maybe never?
Okay, lots of topics there. I think, maybe starting out what we're bullish on, so flexibility in the grid. now we have a lot more distributed energy resources. So both at the sort of consumer side, we have heat pumps and electric vehicles that can be controlled. People also getting batteries and solar on their roofs. And then obviously in companies they're also getting all sorts of distributed energy resources. And that enables demand side flexibility, which we've never had before. So there's a huge amount of opportunity to control that. I think we see the most promising way there is via the energy retailers or utilities, as they have the best distribution, they have the best oversight, they have their own assets also that can be optimized with it. You know, OEMs will never optimize anything other than their particular assets, so they won't go sort of cross brands. And so that's one area that I find very exciting. Also reducing transactional costs. So we have a lot of the technologies that we need, right? We could decarbonize the entire grid using existent technologies, solar, wind, batteries. And yet we are still, you know, we're investing in them heavily, but there's still a long time and high transaction costs for getting them on the grid. And I think with increased data, we can get better underwriting and actually make these more financeable. And then, yeah, I think there's a lot of opportunities and more cutting edge stuff as well. So like AI for verification and operation of fission, nuclear fission, scientific acceleration for fusion, subsurface modeling for geothermal, and many more. And now I've forgotten the rest of your questions.
That's very exciting. And of course, as we are also a very tech-driven investor, we love to dig into these topics. So let's talk cutting edge, Christian. Let's talk tech. What are the most recent breakthroughs in machine learning that will power the biggest opportunities in your eyes when it comes to energy?
So actually, I think that the latest cutting-edge development is that you can converse naturally with computers, because that wasn't the case until, let's say, recently, so let's say 2 or 3 years in the past. And that's also actually a bit one of the themes of the startup we founded last month, where we want to somehow automate the complete chain for an energy supplier end-to-end. And end-to-end means also towards the customer, yeah? So that actually we can serve the customer at scale, which currently is only possible using actual humans. And we think that we can leverage a lot on the latest developments in LLMs to give a great customer experience. And also with the, let's say, the latest developments in LLMs is that now also you get a number of scientific papers and companies forming around predictable LLMs, so that at inference time, at the time when you get, let's say, the LLM output, you can already get a kind of a figure about how reliable is the output. Because I think that's actually the last stepping stone that we need to overcome in order to use those models at scale also in more sensitive areas. Yeah? So not just doing funny pictures of cats on the internet, but maybe also operating assets or orchestrating other agents that run on traditional models.
So maybe a question to both of you. I mean, there is a tremendous amount of opportunities that we obviously see now that AI is becoming so powerful, and at the same time also the market is so open for new innovations, because there's a lot of challenges around energy and energy availability, and make things abundant if possible. But maybe also let's talk about the bottlenecks. Like, where are the bottlenecks in terms of energy? Are they around data availability? Are they around, you know, model quality, or also interoperability of the different grids? What are the biggest challenges when it comes to the technical side of things?
Is this a question for AI on the grid, or just generally in AI and energy?
Maybe answer both. I think both are really interesting.
Yeah. So I agree with you on, like, the grid's not going to be fully AI run. There will be increasing optimization, not using LLMs, but as you said, AI has been already integrated massively, and I think at the high voltage level with the TSOs, you have a lot of data. Actually, it's very transparent, and already they have a lot of sensors to track that. And yet at the distribution level, so the low voltage grid, we're kind of running blind. And in Germany particularly, not only do we not have great sensors of what's going on, but the companies managing it, like the distributed service operators, can't deal with the data, because unlike every other country in Europe, we have like 800 or 900 DSOs. Everyone else has like 1 or 2. And these are very small companies that don't know how to deal with large amounts of data. It's not something that they've previously needed to think about, because it was always a lot more controllable with just one power station rather than all these distributed energy resources. So I think, sorting out that would unlock actually a lot of different business models within Germany and the rest of Europe. So that's a bit of a blocker. And then I suppose in more general AI energy, I think a big blocker is selling to grids and utilities. It's not it's understandable. They're looking after our most critical underlying infrastructure, which is powering our world. So we don't want them to be taking big risks, working with startups. But there is it's a very sleepy industry. We have to speed things up if we're going to cope with the challenges of the 21st century. So that's one challenge. And then I think other than that, maybe on sort of these, we see a lot of AI for site selection or permitting or doing kind of individual parts of the piece, which are more or less fine-tuning LLMs. And I think that is going to be quite tough to get real defensibility. You can grow quite fast, but for at least a venture case, what the kind of outcome we need to see, it's quite tough to really differentiate in that space and grow fast enough that you can outpace the others without a lot of fast followers coming in. So I think actually there's more potential there for like vertical integration and going into actually owning and operating the customers that you used to sell to, because you can actually you can realize a lot more of the potential gains in AI if you're an AI native company than if you're a old school energy company who's now been sold the software that half of you don't want to use, the other half don't know how to use, and it's like very minimal, the actual realized gains. So there's, sorry, I don't know if that fully answers your question. Few parts that are blockers and challenges in the space.
So I personally think, let's say, one of the big benefits of having AI in the current form is that it's possible to, let's say, emulate humans doing certain tasks. Yeah, so you can automate away a lot of repetitive tasks and also tasks that take a lot of time, but actually are rather low to mid value. And that would liberate people in the energy companies to do more high value tasks, or to, let's say, orchestrate a number of agents, and you could 5 or 10 times the productivity of people. The other thing is we have a real shortage of experienced people in the energy industry. So actually in my previous jobs, when we had to hire specialists, it took 1 year or 1.5 years with headhunters to find certain profiles, because they are simply not on the market. Yeah, it's a huge problem. So if we can empower the people who are already there to do more work using agents and LLMs, I think it will have a positive effect on the whole industry.
And I think what Jessica said, Christian, was a wonderful segue into full stack. So maybe we wanna walk us through why you decided to go full stack when building Fundamental, because obviously, when most investors hear full stack, they get scared because full stack is complex, takes some time, and you really need a bit of patience to build the full stack company. And yet you decided to go there, and we love it. But maybe you walk people through what was your thinking behind, and how you actually also do it. So maybe go a bit in depth.
Yes. So first of all, I don't want to come across as someone who, let's say, tries to beat up the current industry, because I think the industry is doing an excellent job, also with all the constraints and the problems of the last years with the war in Ukraine and other problems. So the energy industry solved all those problems. We didn't have an outage yet here in Germany. That's excellent work. Still, I think there's lots of benefits to be had if you can operate things, let's say, more in an integrated way. Yeah. So what we need somehow, I think, is a kind of a new operating system for energy in general, where processes link, let's say, with each other without any kind of friction. And so rather than building just another, let's say, player in the middle, we were thinking we now have the luxury of starting on a blank piece of paper and drawing a map how we would design an energy company without any legacy constraints. And that's the beauty of it, because now we can think really very customer-centric, how we want to build the whole chain in the, let's say, most cost-efficient way and in the most practical way.
Maybe one more question, and then I have another one for you, Jessica. So the obvious next question an investor will ask is, okay, great. How can you show me already now that your thesis is right? And then second question, even more important, how is this going to be defensible? Like, how can you defend yourself on the market?
So the first thing is by, let's say, first trying to focus on the biggest bottleneck or the biggest pain points. Yeah. So the beauty of the energy industry is that it's quite modular. So you have lots of service companies doing parts of the chain. And if you have good connections into the market, you can get in touch with people who can serve you on those ends that you don't build yet. So in some way, it's a kind of a make or buy decision all the time. Yeah? And obviously, we will start with the biggest bottleneck, in our opinion, first. So looking for, let's say, an underserved market segment, talking to that market segment, finding out how can we serve them better, building the tools and building the interfaces and getting service companies to do the full supply. And then over time, tackling the next problem and then the next. Yeah? So we sort all the problems in descending order and we solve them piece by piece, and that's the way to go.
Jessica, you did a great job, I think, before describing all the bottlenecks, challenges, and constraints to the energy markets, which then, of course, also translates into the constraints for all companies building in that space, right? So energy really isn't the easiest space to build a company in. And we as investors, we love fast-growing companies, right? And fast-growing companies usually are a hard thing in constrained markets. Also involves a lot of hardware and a lot of dependency on some factors that cannot change that quickly. When you think about the whole value chain of the energy market, what are the areas in which you think it's still possible to build venture scale companies that can show this growth and also ultimately the resilience and defensibility?
Yeah, good question. Quite excited by the growth in data centers and how we can better optimize them, both in sort of off-taking and trading the excess capacity, because they're all working quite under capacity majority of the time. And within the data centers, optimizing compute, cooling, and energy efficiency generally, which also with AI has some companies are getting some interesting gains. So that's one. Also, I think double clicking on the full stack and vertically integrated, as you said, a lot of things can be automated throughout the process, which can then, rather than just get a small gain, really drastically improve. And then margins. And then finally, a little bit on industrial demand flexibility. So quite a lot of industries, they do have loads that are dispatchable and that you can alter. Problem is selling to industrials, also not easy. Maybe a little self-advertisement, but we're currently publishing a playbook on industrial go-to-market, and I think it's increasingly interesting for industrials in Europe. We're having this whole push for reindustrialization, and energy costs are just really uncompetitively high here. So there is an increasing interest, and if you can build a software with a fast time to ROI and a clear ROI in terms of optimizing their loads to be at the lowest cost, and that also means highest renewable energy of the day. If you can also convince them to do it, because they also have other priorities, so you have to really understand how to navigate internal politics and really nail that sales process. So check out our playbook.
That's a wonderful one, and thanks for putting in all the work, because you're gonna help a lot of founders and companies out there. I'm very sure. So as Christian pointed out before, energy is super important for society, and thus it's also highly regulated. So maybe if we stay with the constraints for a moment, what do you generally advise founders how to navigate the regulatory maze? What are the things you really need to comply with from day one, and maybe also what are the things you can be a bit more lenient on? Because if you're going to focus on everything at first, you're never going to build a company, right? So there's also a bit of risk taking in here.
Yeah, it really depends on what you're building. I think going back to the grid, we have this new European regulation on AI, which really puts a burden onto the startups. So that is really regulatory constrained. On the other hand, the clarity that gives, I think, also makes Europe quite a good test bed, because it actually increases trust if you can go through that compliance. And then I think maybe more cross-cutting is explainability. Very few customers want to trust a black box, so it's important, rather than to replace physics with AI, but to have physics-based rules as well as AI, so combining the two and having some supervision level with these deterministic rules that kind of prevent any kind of hallucinations, right? So if that comes through, that they can actually have that safeguard and take you back to the baseline strategy. But again, that's particularly with grids. I think I couldn't tell you all of the regulation you have to go through, and I don't think any of you would like it, because it would take hours and hours, I think, of going through. And everyone has, every product has different ones, but I think explainability is a huge part across the board.
So Christian, let's talk about explainability, or let's talk about what happens when the AI gets it wrong. Like, what are the scenarios that you think about when now building your company, and where are areas where you want to build guardrails so that even if AI gets it wrong, still we don't have a blackout?
Yes, so it's not only the blackout, it's also the financial damage that can happen. So in energy, it's important to forecast the load of the next day every day before noon, because that then determines the market prices of the next day, and also gives let's say the system operators the opportunity to secure balancing energy if needed to maintain the grid frequency at 50 Hertz. So actually, if you blindly trust models, you might totally misforecast the next day. That can be very expensive for you. That can even wipe you out if the damage is big enough. And also it causes big trouble in the whole system. So I think it's definitely necessary to have safeguards in place. So I think a rather straightforward approach for safeguards is that there is always a final human check before you submit something of a certain significance. Yeah? So if I need to submit something once per day, there's no reason why no human should look at this before it's submitted. But while it's being compiled, AI can obviously orchestrate this whole process. Yeah? So it's a bit like with those coding agents. They do some crazy stuff, and before you hit the enter key, you must put on your brain, because I read the other day on the internet that some guy formatted his hard drive because he let his AI run loose on his computer and then was shocked that the AI deleted everything. So I think that's the typical case where you need to put in some guardrails. So actually, also coming back to the previous topic, I think building in Europe with a strong regulation is actually not a bad thing, because also it, let's say, makes it more difficult for you to do crazy things in building something, because you need to comply with certain rules, and I think they are there for some reason. So as long as you do things in a proper and controlled way, you will always comply, because I think the goal of the regulator is not to destroy business, but just to make it more let's say, safe to operate. Yeah, and that I think also is, if you build something successfully in Germany or Europe, I think you have passed the test that what you have built is quite stable and that you can also roll it out to other markets.
Jessica, let's talk Europe. When you invest in companies, you obviously also want to let them scale in Europe. So energy markets are regulated. I think they're also regulated sometimes on a national level. Then there's probably overarching regulation. How do you like help companies to understand the regulation and also what makes you decide to invest in a company, and how do you assess how easy it will be to scale that Europe-wide?
Yeah, again, I think it depends a little bit on the model of the company. There is increasingly EU-wide regulation, and there is also a push for more flexibility in the grid across the board, but it's very much a work in progress. There's still a lot of differences between different grids, both in terms of the energy mix and in terms of regulation. Depends again if you're talking about the high voltage or low voltage, because high voltage, there's already a lot of cross-border action, so that is more aligned. And there's also sort of different parts of Europe, like the Nordics have slightly different to the rest of Western Europe, and so you can more easily get across Western Europe if you start in Western Europe, for example, than if you start in Scandinavia. So that's maybe on the regulatory side. I think it's all fairly solvable with technology, so it's not the biggest bottleneck. I think the sales motion is often more difficult if you're going towards utilities. But I also think maybe in a call to action for Europe is that it's a great test bed because we have such a high penetration of renewable energy, at least in certain countries, some less, but overall we're very high penetration and really high penetration of distributed energy resources, like a lot, in Germany particularly, a lot of solar, a lot of batteries, a lot of electric vehicles. And that's how the future will look. So it's fantastic to start building here because your technologies are only going to increasingly be relevant to the rest of the world.
Let's assume, so there's a company that started out in Germany. Are there scenarios in which you can think of a moment when you would recommend them not to actually start in Germany, but maybe start in a smaller market? Have you seen these kind of playbooks playing out well, trying to start in a smaller market and then scale to larger ones?
It's a great question. I think there isn't like a wrong or right answer. If you start with Germany, it's a lot more expensive because usually there's already competitors, it's a very big market, and on the other hand, you've proven once you do scale in Germany that you can scale in a very competitive market. So yeah, I think generally speaking, if you can start in a big market like Germany, you're off to a better start than if you only prove out in a very small country and then you have to convince investors with no proof points at a certain stage that you can expand internationally, and that's a harder sell than saying we've already done it. That said, I think, as I mentioned before, Germany has a specific issues with distributed or DSOs and sort of the low voltage grid that makes actually flexibility really hard to do here still. So it could be the case that if you're going for that flexibility play, it makes more sense to start with a bit more sophisticated distributed energy grid.
That brings us to the obvious next topic of geopolitical setups, right? So they do matter because they do inform regulation and political directions. What's your take right now? Like, I understand that in a lot of ways we are living in a great moment of time where there's tremendous opportunities. At the same time, there's also so many new developments, and some people say the old world order is done, has been or is being replaced by a lot more patchy, kind of like opportunistic collaboration between the different actors. Maybe on a high level, and then also feel free to dig in. How do you think about the geopolitical landscape and these three blocks like China, Europe, the US? Both of you.
So actually, I think it's a good stimulus for Europe to catch up, because I think there is some catching up to do. But I still think that we have very valuable companies also in Europe, and we should have the spirit of playing in the first league. Yeah. So I don't share the opinion that we should put ourselves in certain niches, because we can never be, let's say, as cheap on the power side to run let's say, mass-scale data centers, or we don't have the capacity to produce so many chips, because I think it's not only about where things are manufactured, but also where the design is happening and where people are thinking about the next generation of things. Yeah? So we all don't know what's happening in 1 year or in 2 years. It's still totally uncertain. And maybe in some basement, someone is developing something really hot, and that can also be in Europe. Yeah? So I would take it as a motivator and trying to understand, to catch up with the knowledge and to go beyond that.
Yeah, I agree. I think it's not achievable and not desirable for us to be fully self-sustaining. I think that's out of the question. But there are certain parts that are critical and that we shouldn't rely totally on other nations for. I think in the same way that energy has powered our lives up until now, AI will be the base infrastructure for our lives going forward. And just as we wouldn't rely on all of our cables being owned by, I don't know, another country, China, let's say, you wouldn't rely on all of we shouldn't rely on all of our data centers and chips and models to be produced in Asia and the US. So we also need to build that capacity here in Europe, and I very much think we can. And I see some tailwinds for it also from policy and innovators. We have a lot of catch up to do though, so we need to really speed that up. I was last week told the statistic that we are very much close in being third in patent production for AI. So we have great research on AI, basically, third in the world after US and China. But we're really lagging in terms of the amount of notable models that we've produced. And I think that's just one part of it. We're also lagging in a lot of other more hardware infrastructure. But I think it's really, we need a call to action for Europe to catch up in that sense.
Please hold that thought, because I'm going to ask a moonshot question as my last question before opening up to the audience. My second last question, however, is about the future. I think both as a founder and an investor, we do think a lot about the future, because we obviously want to model things the way that it's a fit for the future, or we even are able to create the future ourselves. Maybe guide us through your thinking, how you think about, let's say, the year of 2030 in 5 years from now, when it comes to energy and energy markets. What will have changed? What is your current assumptions about how the market will look like?
So actually, I'm a firm believer that there will be a new energy operating system. Yeah. So because I think it's the logical way it needs to go in order to cut down cost and complexity. So I think it will be actually kind of a battle of different approaches or teams in the years up to that year. And then finally, it might be a winner-takes-it-all thing, that the most efficient means of organizing energy flows in whole Europe will win. And I think it will integrate the complete chain. Yeah. So let's say from the production to the final customer, you will have, let's say, a straight-through process, which is really very cost-efficient, which runs at scale, and which utilizes latest technology. That's my personal belief. And of course, I want to be part of that.
Yeah, I agree. I also think maybe it's a bit contrarian, maybe it's a bit further out than 2030. But I feel that a lot of the complexity in operating the grid is archaic, and it's from a time when we could only control production. So we had to have all of these different ways of bidding and all of these very complex markets to make sure that we could match exactly the demand. But now renewables and distributed energy resources in the meantime make it much more complicated. But in the longer term, it gives us control combined with AI and like better optimization and technology there and better forecasting. If we could have fully accurate forecasts and control of demand to make up that sort of that margin of error, because we can control lots of different industrials. We can control everyone's electric vehicle, which is plugged in. We can control everyone's heat pump a little degree or two. And it's fully automated, right? So you still get your warm home and you still get your running car. Then we could really rethink the way that the grid is working and make it much more efficient and simplified. That would require a huge sort of movement from policy and regulators as well. And it's, again, a really critical part of our world. So I think it's going to be hard to do. But in the meantime, I see a lot of opportunity to also treat consumers more like an asset. So there's actually, if you have an electric vehicle and potentially also solar, maybe a battery, maybe a heat pump, there's no real reason why you should pay so much for your energy because you're an asset. You are able to give flexibility to the grid, you're able to power the grid. So I think radically reducing costs for consumers and industrials and treating them more as an asset than a customer.
You spoke about archaic. Let's talk about archaic times. Let's combine that with the moonshot. So let's assume you're queen or king of Europe, and you've got one moonshot. You've got one initiative you can start. What would it be?
Well, actually, I think I'd put in place a regulation also with a target to say that the degree of autonomous operations in the grids must increase every year by a certain extent, in order to force out, let's say, old legacy structures and, let's say, motivate everybody in the field, not only the startups, but also the big players to improve the whole process.
It's a good question. I think AI is going to create massive changes in the market. And just as we've had huge economic transitions previously, it creates a lot of disruption. So I think actually I'd do something more social, like a universal basic income, to enable people to move through this transition and feel that safety to fully embrace it and embrace what it could mean for us as a society, rather than sort of everyone trying to protect their own position and stick their heads in the sand so that they don't have to realize it. And I think, that something to enable that transition in a more mindset of abundance rather than scarcity.
Jessica and Christian, thanks a lot. Please give them a big hand. So let's open up the audience, and we'll have Stephen to go through with the mic.
Here I am.
Hi, my name is Greta. I have a client. We are selling an AI-based demand-side optimization product for commercial to utilities in the US. And before we went to market, we had the assumption that the utilities wouldn't react with a lot of interest. And we've had overwhelming appetite for it, which has been really surprising. And my question is, what do you think motivates the assumption that the utilities wouldn't have interest or are more careful in the European market?
Maybe I misspoke. I do think utilities are increasingly interested, especially as neo-utilities are eating their lunch and forcing them to act, right? Like you have Octopus coming into Germany, we have Rabocharge and a lot of other players. So I do think they're increasingly interested. It's just that the sales cycle is not very forgiving. And maybe it's better in the US, but definitely in Europe, it's just like you need to, it's not just about the testing and proving that it's, doing lots of simulations and pilots and everything and showing that the technology is itself robust, but it's also just about navigating like internal politics, getting executive buy-in. And so that part of it's just quite painful, but definitely not unachievable. And we have to have someone, as I said, I think that the main way for flexibility will not be mainly via OEMs or sort of newcomers. It will be via utilities because they have that distribution or some kind of energy supplier or retailer. So I think it's great what you're doing.
So actually, I think that shows that we need some kind of universal operating system, some harmonized interfaces to bring down the cost for the implementation, because I think a stepping stone could be for utilities to adapt to new things and adopt new technology is always that it's very expensive. Yeah, so they need to dedicate people to run the projects. They need to maybe change a lot of things in a lot of systems, and that comes at a very high cost. And if we could bring that down by harmonizing things, I think it would be a huge leap forward.
Thank you for the opportunity to ask a question. So the thing is, I'm a physicist, and I have to admit I disagree with most of what you said and you're predicting. So just to give some key points. First of all, 75% of the electricity in Germany is consumed by industry, traffic, and economy, and not by households. It's just 25%. So the thing is, when you're talking about like demand flexibility, what you actually mean is managing scarcity. It's not a good idea to manage scarcity, because what companies will do is they will leave the country, and this is actually what's happening in Germany. Just to give you an idea, like until 2020, the wholesale electricity price in Germany was 3 cents per kilowatt hour. Now it's 10 cents. You're not seeing that on your electricity bill, because the government just decided, to pay some of the taxes and all that stuff that is additionally on your electricity prices from taxpayers' money. But the thing is, they can't do this for the industry, not at the scale. So the thing is, what we actually need, we need more generation stations. And the only solution to that is nuclear power, because that's the only technology that can be scaled. And you can see that in France. In France, the electricity prices for households without subsidies, there's no subsidies. I know people claim that, but that's not true, is 20 cents per kilowatt hour, 20. And I'm sorry, this is not going to work out. I mean, you're not going to deploy an operating system on the grid. The operating system is not going to change if there's not enough wind or solar generation, and you can't store all that energy. I mean, we consume 1.6 billion kilowatt hours of electricity per day in Germany. Try to figure out how many Tesla cars that is. That is like 16 million Tesla S cars. You're not going to store that. Just forget about it. I'm sorry, but I'm sorry to burst your bubble, but that's just physics.
Yeah, so first of all, thanks a lot for your comment. It's very valuable, and maybe there is a misunderstanding. So I wasn't saying that the operating system should be the grid, and that will solve everything. My reasoning is we need an operating system for the complete chain of the energy industry, not just for the power grids. Yeah? So for that reason, I totally share your view that the generation is the key to solve the problems. Totally agreed. And also, I believe that we need to be very competitive also, and to enable competitiveness for the mid-sized companies. And that's actually the goal with our startup, to bring best bespoke service and cheapest sourcing conditions to our customers. And I think the means to get there over time is to reduce the total system cost. And this is what I was talking about. Yeah? So the operating system is not the grid, but for every process within the energy industry, from the production to the final customer.
have like a comment and two questions, one to Christian, one to Adrian. The comment is a very important point that you have raised is the Germany basically is the ultimate test for any company who wants to, or any company in energy that wants to bring an added value, and it's extremely important that startups succeed, otherwise we will be, sorry for the bad word, fucked up by other external, like AI companies who are good at advertising and coming, and by kind of propaganda convince big utilities to work on them, and we will compromise a lot. They will lobby the politics, they will, because they are good at this, and I appreciate the courage that you are taking in like working this, but you have of course a big challenge, and this is the first question to you is, we have in Germany, if you consider just the grid operators, like 5 big TSOs and about like 860 like Stromnetzbetreiber and Stadtkraftwerke, so the small, and they are extremely fragmented, and not just in the operation but also in the data. And the data is, for anything, is AI without data will not much work. So how are you going to handle this whole fragmented market to connect everything together? And most importantly, how are you going to handle the data? Because data is fragmented in different source systems, and the quality in different SR-based systems are not good. So this is the first question. And what, if you would like to detail a little bit, what do you mean by operating system? Because the word operating system is a bit ambiguous. The second question is to Adrian.
Maybe let's start with the first one, and let's all try to be a bit more brief in the questions, because we have a lot of people who wanna get their questions done. Okay, thank you.
Yeah, so first of all, also thanks for your comment. So I totally agree, it's difficult to integrate everything. So you have the 4 TSOs, you have the 900 DSOs, you mentioned it. Fortunately, there is, let's say, lots of data exchanges already in place. They are also regulated. You have 2 format changes per year. So you can read up how the market works. Yeah? So you have message formats and how the message is transferred. And this is all things that you can automate. And there are also players in the market since 2016 who automated a big chunk of this already. Yeah? So it's the brand with a nice water animal. And so actually we strive to take this to the next level, to further automate, to further simplify processes. Because also having format changes twice a year means twice a year a lot of companies in Germany servicing, let's say, the industry need to, let's say, stop doing anything else and just working on those format changes. So the first question would be, why do we need 2 format changes per year? Can we maybe streamline this a bit? And operating system means, for me, you have clear message protocols, you have clear processes. Those processes must be machine learning and AI friendly so that they work well with automated systems, and the overall goal should be for the complete system cost to go down, because then the suppliers have lower cost to serve, they can pass it on to the customers, and then we can be also more competitive in the world market if we have cheaper final energy prices.
Are you okay to take this question? Sure. Yeah. Thank you. The question is, I'm going to make it very short. In the startup in Germany specifically, we have been seeing now these big players like Microsoft, Google, Anthropic, Mistral 2 days ago coming to Munich and targeting the enterprises so aggressively. For example, the list announced with Telecom. How do you see startups competing with these big players, and what is the edge they have over these big companies? Thank you.
Yeah, no, I mean, that's a great question. And I think it comes down to a very, very fundamental one. So we view machine learning as a commodity itself. So think about machine learning as you do about cloud compute today. So there's going to be a few players who basically service you with AI coming out of the wall. So the basic models will be cheap, if not free. So don't try to be a model provider. That is my first point. There's not going to be an edge, as it never was with any type of technology, right? So What we're interested in, what happens on top of the technology. What type of business models can you build today, because AI, machine learning is working. So think of the other revolution, the internet era. Nobody talks about internet technologies today. Everybody talks about the applications that happen on the internet layer. And these are the business models we're looking for. So, and there is a ton of opportunities into each and every vertical you can think of. What we don't believe in is when you go too horizontal and try to offer a solution that is a fit to every industry, because then again, you're going to the commodity layer. So try to be on the vertical layer and try to solve real customer problems that then can scale.
We have time for one or two more.
Wir hatten erst 2 Fragen, okay?
Okay. Hi, Max here. Just wondering, I think you said something like in Germany it would be a good proof point for a business to start when you tackle all those challenges. And with regards to maybe operating system, energy operating system, I thought, is Germany, like, to cover this, you need to cover the, let's say, a lot of the complexity of the energy market environment. And my question is, wouldn't it be easier to start in an energy market environment that has less complexity than Germany and maybe also is more in the future already?
That's actually a very good question. So the thing is, I enjoy living in Germany. I enjoy also working and building in Germany. And of course, in other jurisdictions, it might be a lot easier because you have less players on the market. Yeah? So you don't have 900 DSOs, but maybe only a handful. But at the same time, I think this is not really a blocker for me, because I think we want to develop a system that scales, yeah? And then it doesn't matter if it's 5, 10 or 900, because if the underlying architecture is sound and you can do with, let's say, little overhead transactions over the system, it should work quite smoothly, yeah? But again, also, I don't want to boil the ocean, yeah? So I need to start in one segment. I need to let's say, find an efficient solution for all the, let's say, challenges, and then I can solve the next one. Yeah? So I will not single-handedly rebuild the operating system in Germany, but my vision is that together with other builders, we will find a very efficient way to serve the market. And that's a bit the idea behind that.
Sorry. So, really, in English, what is this? Not a wall. This is sorry. Huh? Because of this, I didn't see him. I always looked, where is the person with the micro? So, I'm a change manager, and I have in my when I studied, it was yesterday, I think, I hope, I was involved in the development of systems for car safety at Daimler Chrysler, and there I have had the possibility to see the driving simulator. And now in my leisure time, I developed something like a flight simulator for actors in complex systems, and I see the problem or the challenge that we only look at this highly complex sector only in fragments. And I tried to develop a simulator which provides a whole system view with concrete data and not only guessed data, making the real estate, the hidden friction losses, and yeah, but no, it's not.
Okay, do we have one final question maybe? Okay, very short. Okay.
Actually, what I'm missing here is a use case, a real convincing use case, either implemented already or at least potential for AI, for machine learning, for neural networks. I didn't see any, to be honest. Not from the usual chatbot or whatever, sorry.
I've got a use case for you. So actually the startup we are building, we intend to give 20 to 30% cost savings to mid-sized businesses, automating the whole chain. Yeah? So we will be on the market early next year. And this is a concrete application of this. Yeah? So by starting from scratch, developing processes which are very lean and customer focused, and putting them into the existing energy system. And the goal is over time to, let's say, tackle the next problem, as I said in the beginning. And the end goal is to come up with an overall very lean system in the next couple of years.
So maybe we have a couple more minutes, right? So we can go for more. So I didn't want to interrupt you.
Was that a question directed to him, or did you also want general?
I wasn't convinced from any of the potential use cases.
Yeah.
I didn't see any. Like a chatbot, like process automation in the administration, research and development. Where?
Well, all of them. I suppose research and development, I mentioned accelerating science for fusion. And you want to have like a very deeply specific. Then I mentioned fission and also geothermal, the ways that you can model the subsurface potential for geothermal, and then maybe on the process optimization, there's reducing transaction costs. So being an AI-powered underwriter for financing renewables, through to more, as I mentioned, site permitting, site selection and permitting. I don't think makes sense to just do a fine-tuned LLM, but you could be a full-stack developer, like IRR, or IPP yourself. And then through to more the demand-side flexibility, so you can do load scheduling for industrials and control their dispatchable loads, through to more consumer-facing, where you can optimize their use in the home, via connection through to their distributed energy resources. I think there's a few there that answer different parts of the chain, but maybe you're looking for something very specific for me to go through, like deeply what they're doing, or okay.
Not really convincing at the moment. That's all I can say, but I think it's interesting to talk later about this issue.
Okay, sounds good. Thanks.
Do you have? Are you up for 2-3 more questions?
Yeah, hi, hello, thank you. I have a short question because we are currently the most focused on the energy distribution and the production. So I have a question regarding the energy storage. So I would like to know, I mean, your opinion, or even for example, the status quo so in the European market about this, area. So for both of you, maybe.
Yeah, so actually I think storage is very important, because with energy storage, with batteries, for instance, in Germany, you are able to, let's say, swap hours. It's like a time machine, yeah? So you take the most expensive hours of the day and you swap them with the cheapest hours of the day, and that leads to savings. And then it depends on your, let's say, business plan that you will amortize your storage after maybe 3-4 years, and it will last 10, 11, 12 years. I now also spoke to another person telling me latest research is they can even last 15 to 20 years. So I think storage plays a very important role in the German energy system, as we don't have a lot of hydro like other countries like Spain or so, but we need to come up with flexibility ourselves.
Yeah, I'd say maybe additionally we see a lot of companies raising VC money that compete in PE markets, because we are quite behind in Germany in building out long duration energy storage. And so there is a huge margin that you can make right now. In the longer term, I'm not super bullish on this as a VC case, and maybe I'll be proved totally wrong. But you do cannibalize one another as soon as you build out, long duration energy storage, because you're essentially have the same capacity as your neighbors. And the costs of batteries are dropping really fast, which gives you great tailwinds in the future, but also means that assets that you buy today are going to be competed with much cheaper capex in the future, which over time I think will erode margins. And with so many VC-backed competitors entering the market with pretty much the same idea and same offering. I think there'll just be a lot of cost war, like pricing wars, and and also the cost of sort of acquiring, either if you put it on industrial sites, will go up because the low-hanging fruit will go, or if you put it on more greenfield sites, the sort of ability to get permits is getting much harder because, there's a huge backlog of applications, and so people are selling the sites that they've sort of got the permits for, and that's just getting more and more expensive because so many VC-backed companies are trying to buy them. But definitely, if you're not going for a VC venture case, it's a great business to be in at the moment.
Hi, I'm Hans. I head up the European business of Aurora Energy Research. First of all, I'd like to thank all three of you because it's very easy to have downbeat discussions about energy these days, and I think you, all three of you, made it very constructive and upbeat, which is nice. The question is, essentially, when we talk about the concrete examples, you're all talking about fairly asset-light things like flexibilization, better data infrastructure, and so forth, and not about small modular reactors, fusion. I mean, we had the question about it. Okay, the colleague's just leaving. Could you maybe talk a little bit as to why, from a Planet A perspective, you're not going into those kind of things, or I guess from a fundamental energy perspective, why you didn't fund the next SMR company or fusion company?
Yeah, we're very bullish on that. I just didn't talk about it because it's not really that AI relevant. I suppose the more the asset light ones, there's some AI, but it's not really the fundamentals. But I'm super bullish on small modular reactors. I think that you reduce a lot of the waste issues, much more, less cost overrun, much more buildable. And we also have an investment in supercritical drilling for geothermal, because part of the problem right now is geothermal is limited to where the earth crust is very thin, but with these plasma-based drills, you can actually cut through that rock and make it viable to get geothermal throughout the world, including in Germany. But no, baseload is massive. We're definitely very bullish and excited by that.
Well, actually, I also think it's very useful. The reason I'm not building in that space is because I don't have the domain knowledge, and also I don't have the funds, or I need to talk to Adrian about this, if we can build an SMR, so I'd be happy to, of course. But still, I think, so we definitely need new means of energy in Germany as well, and we need to see how the technology evolves, and it's helping all of us along the chain if we have cheaper means of energy production.
Yeah, I mean, obviously, it's going to be one of the fundamental technologies, I think, of the future energy mix, and I would be heavy betting on it. I think point for us is there's not a big AI lever on the theme, but I'm very bullish on that.
Maybe time for one more here.
One more question about a topic you've mentioned in the very beginning of your talk, which is you saw plenty of opportunity to solve problems in the field of energy using AI or not using AI. Where would you go to dig for these problems? Where would you find them? How would you find out what to address in detail?
I mean, that's a super interesting question. And I think the way, when I have conversations with founders, and when we work with founders also through the studio, where we actually also build companies from day zero, we often start on the problem side, and we stay there for very long. So we don't talk about solutions immediately, but we really, really want to dig deep on the problems and find as many people as possible who have similar problems, and then start to generalize and build a thesis on how we can actually solve it. So just to give you maybe two examples that are also a bit more hardware heavy, or let's say more complex. So one of our companies in the portfolio is called Deltia. They do shop floor manufacturing analytics, optimizing assembly floors where humans and machines collaborate. They install cameras. These cameras learn what happens there and then come up with suggestions how to increase productivity. So very complex problem. And we had 3 clients who signed up before we even start building a first product. And it was clients like ABB, Viessmann, and IWC, so large ones. So that's typically what we do. And then maybe a second example from our portfolio is Cambrium. They do biomaterials based on protein design, and that protein design is heavily influenced with machine learning, or actually basis on machine learning. And I think it's one of the hidden climate tech topics here, because if you think about the mix of materials that we today use and how much of it is still going through petrochemical processes for these complex materials, if you can actually supply them with biomaterials, then you have a huge impact on the footprint. So this is the topics we get very excited about.
I would double down on that, especially taking Deltia as the example. I think what's important is to first of all talk to everyone in the industry that you can, and then once you've identified a problem across the board, as you said, to really co-develop with a few customers. Ideally like 3 to 4, because you don't want to spread your resources too thin, but you also need to make sure that it's something that isn't just a niche problem for one potential customer, but actually is across the board. And then you need to really like have 4 deployed engineers who camp out, who really deeply understand the problem at the customer's sites or offices, depending on what your problem that you're solving is. And I think that's something that Deltia did really well. And then you can actually like scope quite a narrow problem and create a solution for that. And then often once you've done that first part and got a really clear ROI and can demonstrate that, you realize a whole load of other problems or a whole load of potential for what you're solving, the data you're collecting, and what that could mean for the industry. And then you can go much broader in your vision, because you have to kind of sell to the customer something quite narrow in scope that's really clear that they can sort of get through procurement for that particular issue. But you have to sell to the VCs like a total world-changing vision that you're going to create this whole industry. So it has to be like a sort of two-sided storytelling that you do.
For me personally, identifying a good idea to be automated or the use case for AI would always be to talk to the customer first. Yeah? So you try to identify a real problem, because I think it's very easy to fall in love with a problem and then you develop a solution in search of a problem. That's the worst case. So you burn a lot of time, maybe also money, and in the end, nobody cares. Yeah? So I would just go the opposite. I would really get into touch with people, ask them what is the most annoying thing in a certain industry, and then trying to see, is there enough data to justify an AI approach, or maybe you need to solve it differently. And if you want to focus on AI, obviously you need something that works with a lot of data, because AI only works if you have lots of use cases and data to train it on.
Christian and Jessica, thanks a lot again. Dear audience, thanks a lot.
Thank you.
And obviously, please feel free to stick around. And also, I'm sorry if you still had questions, which I'm sure you have, many of you have. Please feel free to stick around, come up here, and I'm sure Christian and Jessica also will be around for a bit. Thank you.
Thank you.